Hello folks, time to continue with our Module 4 notes. Today we're going to be looking at Lesson 4-6. Lesson 4-6. We're going to talk about fractions of a set. Now we'll go back through and talk a little bit about vocabulary, but this isn't terribly new. We're going to have a different way of modeling it on our paper perhaps, but should be, I'm hoping, fairly familiar. This will be 5 plus 1, so our Roman numeral will be 6. There we go. Fractions of a set. And as mentioned, let's review a little bit of our vocabulary here. Okay. Now, up until this point in Module 4, we've been working a lot with regions. Region. And in case you're not clear on the term, a region is just a solid area or a single item. Every time I talk in class about splitting up a pizza. Okay. A solid area or a single item, an individual item that we are splitting up. Okay. One deck of cards might seem like it's 52 different pieces, but I can treat it as a region. I can treat it as one single thing. Okay, that sounds a little weird. Let's continue. A region is a solid area. And in fact, you can think of it as just those rectangles that I love to draw. Now today we are mostly going to be talking about sets. A set is a group. A group of individual items. Okay. This is when I draw and break things up like that. Okay. Each of these is an individual piece. I'm not going to be splitting those pieces apart. I may divide them into groups. In fact, I will be dividing them into groups. But I'm not going to cut the individual item apart. With a region, we usually do cut the region apart. Okay. Now, building on that, building on the idea of a set, working with the idea of a set, I want to talk about an array. Most of you probably talked about arrays when you were first learning to do multiplication. Might have seen them come up again when you were first learning division. We're going to use them again to help us with fractions. An array is a group of items. So this is looking a lot like our definition for a set, which is by design. A group of items in a special order. So it's not enough just to group the items. They're going to be set up a special way, and I'll show you what that looks like. Okay. All right. Let's talk about using an array. We'll get right to it. Using an array to see fractions of a set. Using an array to see fractions of a set. Let's say that I have 12 action figures. Not unrealistic. And I want to find 1/4 of them. 1/4 of 12. 1/4 of 12. Now, there are different ways I can do this. You know, we talked about how to do it with a region. But if I'm using an array, I'm going to look at the denominator, and I'm going to let the denominator tell me. Let the denominator tell you how many columns to make. Now, what does that mean? Well, if I have 12 items, I want to build an array. I want to build an array that's going to show me what 1/4 of 12 would be. So I am going to make 4 columns. I'll put one item here, One item here, one item here, and one item here. So there's my 4 columns, 1, 2, 3, 4. Now that's only 4 of the total 12, so obviously I have some more drawing to do. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Getting there. 9, 10, 11, 12. Okay, there's my 12. There's my total. The reason I do this, the reason I use the denominator to tell me how many columns, is because now I can split it into columns. One column, 2 columns, 3 columns, 4 columns. And that, in turn, makes it super easy to determine what 1/4 of 12 would be. If there's 4 columns, I am going to take one of the columns. So, looking at just that first column on the far left, that would be 1/4 of 12. 1/4 of 12 is 3. Easy peasy. Now it only asks for 1/4, but I want to show you something. If I ask for 2/4 of 12, that's going to be 1 column and 2 columns, right? So 1, 2, 3, 4, 5, 6. If I ask for 3/4 of 12, that will be 3 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or if you prefer, 3, 6, 9. Now I'm skip counting. Skip counting by this number right here. If I go to 4/4 of 12, thank you, pencil. 4/4 of 12, 3, 6, 9, 12. I think a lot of you probably knew that already. The big thing to notice is that first 1/4, or again, whatever fraction you're finding, the 1/4, 1/5, 1/8, whatever, that is super important because then you can just skip count to find the others. Or 2 times 3, 3 times 3, 4 times 3. In fact, this pattern continues even beyond the original number. Okay. This pattern continues even with improper fractions. Because we started by finding 1/4 of 12, I can use that information to find any number of fourths of 12. I just have to do a little multiplication. Let's say I want to find 7/4 of 12. Seems a little odd, but you might be surprised. Okay, now I'm thinking to myself, if 1/4 of 12, oh well, if 1/4 of 12 is 3, and we established that earlier, if 1/4 of 12 is 3, then 7/4 would be 7 times that. 7 times as much. It would be 7 times 3. So here's my thought process, and many of you have probably already figured this out. 7 times 3 is 21. 7 times 3 equals 21. So 7/4 of 12 is equal to 21. 3, 6, 9, 12, 15, 18, 21 if I continue the pattern. We'll go ahead and do one quick example together. Well, I guess a second quick example together. Then we'll wrap up the video for today. As always, if you have any questions, if I'm going too fast, remember we'll go over it in class. Please ask questions. Let me know what I can do to help make it more clear. If I ask you to find 4/9 of 18. 4/9 of 18, I am going to start by looking at the denominator. The denominator is 9. That means I want to basically split this up, pretend I'm passing out cards to 9 people. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I'll just go ahead and continue. There's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I hit 18. 18 was the total number I was working with. By counting it out that way and making sure you keep everything lined up, the array makes it really easy to show how this is going to spread out. Now, I already broke it up into ninths, essentially, because I made 9 columns. So here's 1 column, 2, 3, 4, 5, 6, 7, 8. Now I could just count 4 of them. 1, 2, 3, 4. 2, 4, 6, 8. There we go. Done. But I want to make sure I'm using the pattern I used earlier. So let's go ahead, slide this up a little bit so we have some more room. 1/9 is equal to 2. 1/9 is 2. So 4/9 is again 4 times that. 4 times 2, which gives me 8. And that's the same answer I got when I just counted it out. Arrays are really nice because they're very visual, very clear. You can just look right at them. All right. Again, we'll go over this some more in class. But there's the bell. There's the bell. So it's time to wrap up. All right. Thank you, ladies and gentlemen. Write down any questions you have. Make sure you've got this copied, and I'll see you in class.